this is Britt Caswell with another example video. In today's video, I'm covering example 5 from section 4-2 in the SavvasRealize Algebra 2 textbook. So this example is focusing on graphing a rational function. And it's a little bit different than my previous examples because now it has something squared in the numerator instead of just a linear term. So the process is still going to be the exact same. All right, I'm going to start with my vertical asymptotes. Now remember, vertical asymptotes occur where the function is undefined. So where the denominator of the fraction equals 0. So what I tend to do with these functions before I can find my asymptotes is I tend to factor them. So let's talk about this bottom of the function. So here, my leading coefficient is a 1, so I could just factor this using double bubble. Alright, so my first sign falls down, and to get a negative 15, I have to have opposite signs here. So since I already have a plus, I'm going to go ahead and put a minus. And then I ask myself, what multiplies to make 15? That subtracts to make 2? Well, that's going to be 5 and 3. Now I'm also going to go ahead and factor this top part, which is a nice little difference of squares here, because I know I'm going to need it later. Alrighty, so my vertical asymptotes. Again, it's where the denominator of the fraction is equal to 0. So using the zero product property, I could take each of these factors and set them equal to 0. Sorry if you hear a crash, my cat's having a good time in the background. Here we are, so I'm subtracting 5 from each side, so I get x equals negative 5 for my first vertical asymptote. And then here I'm adding 3 to each side, so I get x equals 3 for my other asymptote, for the vertical part. Alright, now I usually like to mark these like this, just so that later on when I'm looking at it I could see what wildness I got up to. Now for the horizontal asymptotes, that's where we compare the degree, okay? And there's usually only one horizontal asymptote. So the numerator of my fraction is a degree 2 polynomial. And the denominator of my fraction is also a degree 2 polynomial. So if you remember the 3 cases that we talked about in the past several videos, when our cases match, my horizontal asymptote occurs where y equals, and then I create the ratio of my leading coefficients. So my ratio here would be 4 over 1, which is 4. So here is my horizontal asymptote. So now what we need to do is we need to figure out how the graph is going to fill into these places. So what I like to do is I like to identify my intercepts. So here I'm going to find my x-intercepts by taking the top of the fraction, the numerator, and setting it equal to 0. I'm also going to find my y-intercept by plugging in a 0 for x. It's probably faster if I do it into the unfactored form, but you do you, boo. You know what I'm saying? The reason why it's faster here with this form is because the zeros cancel out. Alright, so that's where I'm going to start with, and then I'm going to pick a few test points where I find it necessary to help me fill out the rest of this. So let's figure this out. So for my x-intercepts, I take each of these and set them equal to 0 using the zero product property. So here I'm going to subtract 3. Here I'm going to add 3. So here I get 2x equals negative 3 and 2x equals positive 3. So here on the left, x is equal to negative 3 halves, and here on the right, x equals positive 3 halves, which is about 1.5 for those of you guys who need the fractions. So what that means is that between these two vertical lines, my graph is doing something kind of like this. Now it's worth noting, this can go up and touch the asymptote. So like I'm going to put this into Desmos to check ourselves, but it doesn't necessarily have to touch it. Usually the asymptotes are, like at least the horizontal asymptote, is talking about as we approach infinity or very large numbers. So when we have small numbers like this, like things that are less than 10, it doesn't necessarily have to touch it. All right, so don't freak out that this isn't form-fitting around that asymptote, okay? So now I'm finding my y-intercept. You're going to find that the y-intercept is somewhere over here. So here all my zeros go away. So I have a negative 9 over 5. Oh, that's a minus 15. What am I doing? Over negative 15. And so that's a positive 3/5 if I reduce that fraction. So that's right here. And so that's helping me to get that shape as well. But I still don't know, because remember, every part of this, every section that is separated by a vertical asymptote usually has some kind of curve to it. So to find the other curves, or to make sure I'm not messing up, I need to pick some test points and try them. So here I'm going to try f of negative 6, because that's the next one over. And on this side, I'm going to try f of 4, maybe. And so you could choose which form is easier for you to plug into. You could do the factored form or the non-factored form. I'm going to use the non-factored form just because I think it might be easier, because I have a calculator. If I didn't have a calculator, I'd use the factored version. Alright, so 6 squared is 36 times 4 gives me 144, and if I subtract 9 from it, the numerator of my fraction is 135. And down here, the denominator of my fraction, 6 squared is 36. 2 times negative 6 is negative 12, so I'm going to subtract that. And then I have a minus 15, so I have a 9 over here. And I'm just looking for approximates. I don't really care what it is. I just want an approximate value. And 135 divided by 9 is 15. So at negative 6, my graph is at 15. So it's something over like that. This one also is probably going to do that same thing, because we don't usually have it to where they hug on each side of the asymptote. But it's always good to check, because you always get those dang one-off situations where it does happen. And then you look like the fool for not checking. So here I'm plugging 4 in to see what I get. So 4 squared is 16, times 4 is 64, minus 9 is 55. And in my denominator, I have 16, and then 2 times 4 is 8, minus 15 is a 9. So I have 55 ninths. And again, I just want an approximation here. I don't really care too much what it is. It's 6.11 for f of 4. So this one is actually a lot tighter to the line than that one is. But here we go. So that is my rough sketch. Let's go on to Desmos real quick, just because I want to show you guys that that's actually what I got and why it looks like that. All right. So if I need to type into Desmos, I usually start by setting up my fraction. And so I put those like this. And so now I can actually type in what I see within my fraction pretty easily. So I have 4x squared minus 9. And in the denominator, I have x squared, oops, it should be an x, not a c, plus 2x minus 15. See, so here's very similar to the graph that I drew. It doesn't show our asymptotes in there, which is kind of annoying. Now, if you wanted to, you can draw those asymptotes, okay? The way that you do it on Desmos is you just type them in as lines. Okay, so x equals -5 and x equals 3. So you could see where these guys are approaching those asymptotes. Our horizontal asymptote, I don't remember what our horizontal asymptote was. Oh, it was y equals 4. So there, you can see it. Did I make some kind of goof? Did I mistype something? So you could tell that something's off about the graph. I don't know why Desmos is having the issue, but this line shouldn't be crossing at y equals 4. It should just follow past it smoothly. Yeah, I'm not sure why Desmos is doing that, because if you look, they correct themselves and they go back above it. But to start out with, for some reason, Desmos dunked down a little bit, so that could be a slight error in the programming. I don't know what's up with that. See, you can't even click on the red line. That's strange. But anyway, there's that to help you guys see it. Let's go ahead and let's do another quick one. Alright, so we won't check this one in Desmos. We're just going to go crazy and figure it out. So first thing, right, we want to factor. So here, this turns into x minus 6, no, x minus 2 and x minus 3. Because I have to have matching signs. Down here, I'm going to factor out a 2. So I get x squared minus 5 when I do that. And so when I actually do factor that, I'm going to get x plus root 5 and x minus root 5, which is weird. So when I go to draw my asymptotes or figure out what my asymptotes are, okay, these ones say they're happening at 1. Oh no, that's because I'm just checking my answer. And so I was a little stressed out about it not quite working there. So my vertical asymptotes, again, they're when the denominator equals 0. So I'm going to take the x plus root 5 and the x minus root 5, and I'm setting them equal to 0. And if I subtract the square root of 5 over and I add the square root of 5 over, I get positive root 5 and negative root 5. So that's between 2 and 3. It's a little closer to 2. So these are my vertical asymptotes. Alright, now my horizontal asymptotes, again we compare our degrees. So the degree of my top polynomial is 2. Degree of my bottom polynomial is also 2. So this is a case 3 situation where you just set up your ratio. So my leading coefficients, I have a 1 over 2. So 1/2 is my horizontal asymptote. Alright, so now I'm going to check out what my zeros are. So I'm taking the top of the fraction and setting it equal to 0. So I have x minus 2 equals 0 and x minus 3 equals 0. So if I add 2 over, I get x equals 2 for an intercept. And if I add the 3 over, I get a 3 as an intercept. So that's a little quirky here. It's a little strange. So sometimes when we draw a graph, sometimes we cross this horizontal asymptote. Sorry, losing my words there. When we have a middle part here that's sandwiched. So what you guys are going to find is what did I do wrong? Oh, I'm not doing anything wrong. It's just I'm checking Savvas at the same time and wondering what I'm doing wrong. Anyway, so this one's probably going to cross this horizontal asymptote, and we're not going to freak out about it if it does. Alright, so if I find my y-intercept, I'm just going to plug in my zeros right away. I get 0 minus 0 plus 6, and 0 minus 10. So my y-intercept here is at negative 6/10, which is negative 3/5. And so what's happening is this graph is going like this. And you could check at -2 as well. You'll probably get a very big negative number that makes this almost cubic shape to it. And then I need to check my other values here. So I'm going to check out -3. So if I plug in -3 into my function, I have -3 squared minus 5 times -3 plus 6. And then down here, 2 times -3 squared minus 10. So let's try that. So -3 squared is 9. -5 times -3 is a positive 15. So the top of this fraction is equal to 30. Down here, the bottom of the fraction, -3 squared is 9, times 2 is 18, minus the 10 is 8. And so if I do 30 divided by 8, I get 3.75. So at -3, I'm at 3.75. So this is graphing up like this. Now down here, I'm just going to pick a number to test it. I'm going to pick 3, just because it's on the right-hand side of that. It's probably a more friendly number than 4. So if I do f of 3, what's going to be nice is a lot of these values are going to be the same, right? So I'm going to have 3 squared minus 5 times 3 plus 6, and 2 times 3 squared minus 10. So 3 squared is 9, minus the 15, plus the 6. This is a 0. Oh, I know what f of 3 is. That's one of my zeros in my function. So I don't actually need to test it. I'm sorry, I forgot that we found that. And so without needing to test it, because we already tested it by finding my zeros, I could see that this one's going to go like this. Alrighty, so there we have it. That's example 5. It's not pretty, but it is, it's done. Until next time.